warm up from today. Okay. Yesterday we learned how to do math if it's a strong acid, strong base. Okay, that's super easy math. We're just plugging it into our log equation and getting answers for that. Today we're going to learn how to do the math for the weak acids and the weak bases. So step one, you have to figure out what it is, like either know if it's strong or weak. The weak ones, remember, start with a hydrogen or N and a Q. They do not completely dissociate. When we learned what dissociation was in chapter 4, they're just when the water molecules and their dipoles get in there and separate them. But when we learned weak acids, like, I think you use the word teensy, like just a teensy amount of them separate. Since they don't all dissociate, they turn into equilibrium problems. We need to know how many dissociate, and that's called X. That's what our change is. So these are equilibrium problems. They're ice tables. We're going to solve for X. We do an ice table, we solve for X. That X is the teensy part. That's how much is changing. That's how much is getting dissociated. For a weak acid, X equals this hydrogen ion concentration. That's our change. That's our hydrogen. And then from there, we can do our pH equals negative log of the hydrogen ion concentration. Weak bases have some kind of amine group. Sometimes it's in the middle, sometimes it's at the beginning, sometimes it's at the end, sometimes it still starts with hydrogen, but you're looking for that nitrogen. Those are going to be weak bases. Okay, same game. They're weak. They don't completely dissociate. So we don't know. We have to solve for that. We call that X. X tells us how much the change is. These are equilibrium problems. They're ice tables. We solve for X. Just like we've always done. In a weak base, that X equals the hydroxide ion concentration. It's a base, that's what it's making. From there, we can get to POH. And then we can get pH from there, because pH plus POH equals 14. Before we do some math, I want you to work with your battle buddy and see without looking if you can name the 7 strong acids, 7 strong bases. Try not to use my boot, like use your own periodic table to remember where the boot is. 7 and 8, you each have to say it once. Ready, go. We'll do 2 weak acids and then 2 weak bases, and then you'll have some more time to practice some homework problems. A student prepared 0.1 molar solution of formic acid. So you're going to look at that and maybe use the clue that it says it's an acid, and then you can say, okay, well, that's not strong acid, so this must be a weak acid. Anytime it's a weak acid, that means it's an equilibrium problem. We don't know what X is. We have to solve for X just like we always have practiced. It's found to have a pH at 25 degrees Celsius. It's going to tell us that because the K changes if temperature changes. If it's 25, it's standard. To be 2.38, we're going to calculate Ka at this temperature. So I'm always going to start any of my problems by writing my balanced equation. That's the plus H2O thing. So by definitions, acids lose a hydrogen. If they're a Cu, they're going to lose the back hydrogen. okay? And it doesn't really matter all that much which one you take, but whose loses that one? So it's going to be HCOO minus. By definition, the base gains a hydrogen, so it goes from H2O to H3O plus. Equilibrium problems are ice tables. This is the only one I'm actually going to draw an ice table for just to show you. My initial concentration was given 0.01. Pure liquids do not go in. Nothing has happened. So my shift is minus 1x plus 1x plus 1x. So at equilibrium, I have 0.1 minus x. I have x. And I have x. I was given the pH. pH equals negative log of the hydrogen ion concentration. pH is 2.38. That was given to me. Equals negative log of the hydrogen ion concentration. So that's how I'm going to solve for my hydrogen ion concentration. Now, everybody needs to push these buttons because I didn't know you didn't know how to push those buttons. So double check with your battle buddy, push your buttons, get an answer for that. Ask your battle buddy, can you push those buttons? Right now, ask them, can you push those buttons? Let me see. You get how to do it. Okay. See? Negative 2.38. Got it? Butt pushing. Okay. This is how we're going to get our x. This is this, right? So now we know our x. The question is asking us to solve for Ka. Ka equals our product over our reactants, our coefficients become our exponents. Pure solids and pure liquids do not go in. So it doesn't have water. So it's going to be x times x over 0.1 minus x. And I know what x is. So I'm going to push my buttons. So go ahead, push buttons, check in with your battle buddy. Thank you.
Sorry, my voice is disgusting.
That works though. Got my attention. Okay, so that's how you solve for K. Calculate the pH of a 0.2 molar solution of HCN. So I'm stopping. I'm looking at HCN. I need to decide, is it strong, is it weak, is it acid, is it base? It starts with the hydrogen, so I know it's going to be an acid. It does have this nitrogen, but it's not like an amine group. It's a cyanide. CN is a cyanide. So that's going to be a weak acid. If I want to double check, I look on my appendix dinosaur. They're all listed there. So take a look there. I'm like, oh, okay, I got it. It's a weak acid. That means that it's going to be an equilibrium problem. We have to start by writing our balanced equation. By definition, the acid loses the hydrogen to the base. So it goes to Cn minus to H3O plus. I'm going to go ahead and skip my ice table because I think you get it. So it'd be 0.2 minus x, x, and x. This time I have my K and I'm solving for pH. So my K is going to be x times x over 0.2 minus x. So 4.9 times 10 to the negative 10 equals x, x, 0.2 0.2 minus x. I have a shortcut for you. These would all be quadratics, except it's an equity issue with the AP exam. Not everybody can afford a fancy calculator that can do a quadratic with a button. And so it wouldn't be like equitable for time if some kids had to do it by hand and some kids didn't. So the rule is if the k exponent is bigger than, which means smaller than, -5. So -5, -6, -7, -8, -9, -10. Like if they keep getting smaller, that means that you can ignore this x here. Okay, so let's talk about why. If my k is -10, that means it's like super left, right? And if it's super left, the amount of shift is like teensy, teensy, teensy. And so if this is teensy, 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 0.2 minus a really little number and rounding back to sig figs is still going to be 0.2. So the rule is -5 or smaller. -5, -6, -7. And you can ignore this because even if I did the math, it's all going to be the same. I need you to stop and talk about that though. Tell somebody next to you what the rule is and how come I can ignore that. Ready, go. So that means that my math is going to be 4.9 times 10 to the -10 times 0.2 equals x squared, right? And then it's just a square root, which is equitable. So go ahead and solve for x. And then go ahead and solve for pH. For an acid, X is the hydrogen ion concentration. pH equals -log of the hydrogen ion concentration. Okay? What work do you have to show me? I mean, honestly, you could read this problem and do this entire thing with just button pushing, right? Like, there's nothing really need to write down. But I'm going to give you answers. So some things that you're going to have to show me is at least show me like a K equation with X's and then show me what X equals before you get here so I can create it easier that way. Okay, number 3, calculate the concentration of OH in 0.15 molar solution of NH3. So NH3 is going to be a weak acid. It's not in the hydroxide group. It doesn't start with a hydrogen. It's going to, a weak base. So let's, thank you. Let's write our balanced equation. Bases gain a hydrogen, so it goes from ammonia to ammonium. Ammonium is NH4 with a plus charge. H2O goes to H1O, so 0.15 minus X, and X. What I did not type in the problem and what you need is a KB value, so can you get that off of dinosaur 0.2? Take a look at dinosaur 0.2. It will be given to you. I don't know, I didn't type it in. Find ammonia, get your KB. I think it's 1.8 times 10 to the -5. Go ahead and solve for X. We can use the rule that we can ignore that bottom X because it's going to end up being the same thing anyways. And it just turns into a square root problem. Remember what X is, though, for a base. X is hydroxide. X isn't going to be hydrogen, so we have like a little extra step to get to pH. We can first get to POH. And then when you're done with that one, do number 4 with your battle buddy. Practice writing the equation. You're going to have to look up the KB again. I don't know, I didn't type it in again. For this as well. Okay, so that is an equation that you did on your homework yesterday, and it sort of feels unrelated to what we're doing today, but oftentimes it's a series where you got to find the pH, and then at the end it's like one more step, find the H3O concentration. Okay, can we take a look at that KSP quiz, class?